Okay, AP Chem, let's talk about a concept that seems a little bit like it's a stand-alone unit, but it has to do with concentration. So, in the laboratory situation, you could determine the concentration of a particular substance based on how much light it absorbs or transmits. So, in the lab situation, you would have what's called a spectrophotometer, and you put it in what's called a cuvette. A cuvette is a little plastic square container like such. Now, the path length is how far does the light have to go through. So the cuvettes typically are 1 centimeter like such. So this is the path length right here. So this is B. If you look in your AP reference packet, you will see that this formula is written in there. You're also going to see it a couple different ways where epsilon is the molar absorptivity constant or the slope of the calibration curve. You might see that. So EBC, or you might see some of the other variables differently, but really the important part is the absorbance. So light is either absorbed or transmitted. So let's just say we have a sample of light coming at this. So some of it is going to be absorbed into the solution, and some of it is going to be transmitted through. So the absorbance is how much the solution absorbs. So basically, let's look at the relationship here. So the concentration has to do with how much solute is dissolved in the solvent. So the higher the concentration, the higher the absorptivity. So I want you to think or visualize right now if you only had water. If you only had water, most of the light is going to pass right through. If you had water with, let's say, Kool-Aid dissolved in it, the more Kool-Aid dissolved in it, the less light would pass through, the less light would be transmitted, the more light would be absorbed. So the higher the concentration, the higher the absorptivity. This B value here has to do with the length of the cuvette and is 1 centimeter and less noted. And this particular molar absorptivity constant is the slope of your calibration curve. And that's a constant, therefore that is usually going to be given to you, or you would use a blank to calculate it in the lab situation, which is individual to the substance that you are working with. So the calibration curve or the absorptivity constant will be individual to a particular substance. You are going to do a PhET simulation since we're not in school. You're going to be doing a PhET simulation where you try to understand this. This is a concept that will be covered by the AP exam. But fortunately, all you have to do is be able to plug and chug with this formula and understand the concept of the higher the concentration, the more light is absorbed, the less light that is transmitted. So the amount of light that is transmitted as opposed to the concentration. So the lower the concentration, the more light is transmitted. The amount of light that is absorbed with relation to the concentration. The more light that is absorbed, the higher the concentration. So these are the concepts that you will try to be investigating with relation to the concentration, the molarity concentration. So if you remember, is moles of solute over liters of solution. So the more moles that are dissolved in a particular volume, the greater the molar concentration, the lower the transmission or transmittance of light, and the greater the absorbance of light. So read through the background information and work on the PhET simulation lab.